Custom Resource Definition, CRD, in Google Cloud. A custom resource definition, CRD, is an important concept within Kubernetes, a widely used open-source platform for managing containerized applications. In the context of Google Kubernetes Engine, GKE Google Cloud's Managed Kubernetes Service, a CRD allows you to extend Kubernetes functionality by defining your own custom resources. These resources behave similarly to built-in Kubernetes resources like pods, services, and deployments, but are user-defined, enabling you to customize and extend the Kubernetes API to suit your specific needs. What is a custom resource definition, CRD? In Kubernetes, everything is a resource, and the Kubernetes API has several built-in resources to manage things like workloads, configurations, and services. A custom resource definition, CRD, allows you to define a new type of resource that behaves just like these built-in resources but is specific to your application or environment. Custom resources. Once you define a CRD, you can create custom resources of that type and manage them using standard Kubernetes commands, such as kubectl. Custom controllers. You can also implement custom controllers to automate how these custom resources behave, extending the Kubernetes control loop to manage custom application logic. Example use case. Imagine you are managing a custom application that requires managing database connections as a first-class object. By defining a CRD for database connections, you can handle these objects natively within Kubernetes, just like handling pods or services. CRDs in Google Kubernetes Engine. GKE in Google Kubernetes Engine. GKE. CRDs are fully supported and enable you to extend the Kubernetes API within your GKE clusters. GKE clusters behave just like standard Kubernetes clusters when it comes to CRDs, meaning you can define, manage, and use CRDs in a similar way to any Kubernetes environment. Declarative management. In GKE, CRDs are typically managed declaratively through YAML files. This means that you can define the desired state of your custom resources and apply them using kubectl, just as you would with any other Kubernetes object. GKE Autopilot. Even in GKE Autopilot mode, which abstracts some of the underlying cluster management, CRDs are supported. This allows you to extend GKE Autopilot's functionality without sacrificing flexibility. Example: if you are building a custom CI/CD pipeline in GKE, you could define a CRD for build pipeline objects, allowing your teams to interact with pipelines in a Kubernetes native way, using familiar tools like kubectl. A custom resource definition is usually defined in a YAML file. This file specifies the name of the new resource, its fields, and how it should behave within Kubernetes. Working with custom resources. Once the CRD is applied to the Kubernetes cluster, you can begin creating instances of your custom resource, just like you would with standard Kubernetes resources. Creating a custom resource. After applying the CRD definition, you can create instances of the custom resource using a YAML file. Custom controllers for CRDs. While defining CRDs is a powerful feature on its own, you can unlock even more potential by creating custom controllers. A custom controller watches for changes to your custom resources and acts accordingly. This allows you to implement advanced automation logic and control behaviors specific to your custom resources. Reconciliation loop. Custom controllers follow the Kubernetes reconciliation pattern, which means they continually try to match the desired state, as defined in the CRD, with the actual state of the resources in the cluster. If you define a database CRD, you can build a custom controller that watches for new database objects and automatically provisions real databases, for example, in Cloud SQL, based on the specifications in the custom resource. Controller frameworks. The Kubernetes ecosystem provides several libraries for building custom controllers, such as the KubeBuilder and Operator SDK frameworks. These tools simplify the process of writing custom controllers in Go or other languages. Use cases for CRDs. Custom resource definitions are a powerful tool for creating Kubernetes native abstractions. Some common use cases include application-specific resources. Define CRDs for application-specific objects like databases, pipelines, or backups. Kubernetes operators. Build operators using CRDs and custom controllers to automate complex operations like database management, monitoring setups, or storage provisioning. Infrastructure as code. IAC. Use CRDs to model infrastructure components directly within Kubernetes, such as managing networking configurations, storage volumes, or even cloud provider-specific resources. Example: a team could define a CRD for backup jobs, which includes details about how and when to back up application data. A custom controller would ensure that these backups run on schedule, interact with external backup services, and handle retries if something goes wrong. CRD Best Practices. When working with CRDs, it's important to follow certain best practices to ensure scalability, maintainability, and security. Versioning. Just like any API, version your CRDs. This allows you to make non-breaking changes and provides a way to upgrade your custom resources gracefully. Validation. Use open API schemas to validate custom resources at the API level. This ensures that only valid data can be submitted to the Kubernetes API server. Namespace scoping. If possible, scope your custom resources to namespaces to ensure that different teams or workloads can use the CRD independently. Documentation. Since custom resources are user-defined, document the purpose and usage of each CRD thoroughly so that other teams can understand how to interact with them effectively.